There is some technical glitch, I don't know why it is happening. So 1 minute, just go to this. Okay. Okay, so now it is moving. Okay, so you come across this population and sample. Okay, so when it comes to population, it means the entire population of India. You know, in the example, you can treat it as the entire population of India. But when it comes to this sample, so so when it comes to the sampling, obviously, for example, the population of India is, let's say, 150 million. So out of those 150 millions, you cannot go and check each and every person. Okay. In the census, typically it happens that people go door to door and they take some, information, some data out of each and every single household. For example, how many people live there, what is their education, okay, what is their maybe the salary, whether they are employed, if they are employed, what is their salary, right, whether it's urban or local, okay, do they have basic amenities or not, whether they have a house or not, maybe depending on the you can say government's requirement, people do go with this census, okay, and based on this census, typically government decides which policy to be rolled out for the common people. For example, if in that area majority of the people are uneducated, so obviously based on that people will do the policy making and all that. Okay, so the term population and sample, okay, for example, you have been given some task uh, just to know that whether some drugs works or not. For example, during the COVID time, there was a two drugs that was rolled out. Maybe the, you can say the COVID shield or something. I just forget the name. Covin and Covishield, let's say, okay, Covaxin and Covishield or something, okay. People were not aware that which drugs works, right, whether it is deterrent to this you can say a COVID or not, whether it's providing you immunity or not. So obviously the company which they have made these drugs, they need some kind of a sample to test on, right? For example, they picked up let's say 1,000 people which they feel that they are the potential candidate, and they have given this to 500, they have given this Covaxin, and to the 500 they have given the Covishield. Now just they want to check whether the which drug, the which drug works well, whether they have equal immunity, or maybe Covaxin is more powerful, maybe they are more deterrent, right? So to check that, obviously you cannot, the company, the manufacturer cannot go and take help of a census. They don't have a time, right? So they picked up a the sample, and they perform this task, okay. That is why the sampling works, and based on those samples they decided, okay, Covishield works well, right, because in the sampling they come up with some kind of a you can say some kind of insights that okay, it works, okay. But there is something called, there are two more parameters, you can say the keywords. One is parameters and other is stats, okay. So when you are collecting data from entire population, here you can see in the first in the visuals, when you collect a data from entire populations, then you call it a parameters. But when the stats, when it comes, when you work on a sample, that is why it's called statistics, okay. Stats is more of a the samples, okay. So the data collected from a sample of a group being studied, when it comes to sample, then this stats comes in, okay. And the population mean and the sample mean at the same time you calculate, okay, to come up with some kind of insights out of these samples and these parameters. These are just a formula, these are the same formula, similar formula, but a mu and x bar is the mean. So whenever we come up with some kind of the sampling, we take help of a mean, right? Mean value, we call it a mean value. But when your data is, when your data coming from a population, then we call it a the mu. This is different mu, right? So these are the few terms that I just try to highlight, that whenever you go with some kind of entry level jobs, they do ask you what is a population, what is sample, and what is parameter, what is stats, what is sampling, the mean value, what we typically calculate. So these are the few terms they expect you to answer, right? Because these are some basics questions. If you are able to answer these questions, they know that you have a the solid understanding of a hypothesis testing. Because whenever you have been given, you will be given any you can say the business case, obviously you formulate some kind of a hypothesis, okay, and then you decide to collect the data in whichever format you want to collect, okay. So this is how it typically works, okay. So okay, 1 minute. Okay. So now, is my screen moving now?
Yes, sir.
Yes, sir.
Okay. So actually, someone wants to join, but he is facing an issue. That is why their text is coming. Okay, no issue. So population and sample are I'm just giving you a brief. The measurable qualitative is called a parameter, okay, and population is a complete set. Just go with this some of the the key points which I have highlighted. And the typical part of this population is it contains all members of a specified group, okay. For example, it contains all the members. You cannot take the samples, for example, out of 100, let's say we calling entire population as 100, let's say. So 100 millions in census, we typically take care of the entire population. But in samples, just a few, maybe 100, 200, 500. But also how you decide a sample, we do have some formula. For example, recently election happened in Delhi. There were many more, these agencies. They forecasted that this maybe this X party will get these numbers of seats. So how they have collected this information and the data out of that. So obviously they perform some kind of a sampling. They haven't come to me and they asked me. I was not in that sample, but I was the part of that population maybe. So based on those few samples they have, for example, their sample size was 50,000. So in Delhi elections, they have conducted a sampling of 50,000 people and they have asked few questions. They put up a few questionnaires, and based on those questionnaires, they filled in a few informations, and then they decided that, okay, in this constituency, let's say in Lakshmi Nagar, the party X is gonna win because they had a few sample of, let's say, 500 people or maybe 1,000 people. They asked randomly, right? And based on the random sample, they decided that in a Lakshmi Nagar, this party will win. Maybe sometime they do have a further level of information that how much the margins they also predicted. So this is one sophisticated way of taking the samples and then deciding, right? This is also one of the key factors, and on the top of it, it's the hypothesis testing that works, okay? So for the hypothesis testing, okay, so what is hypothesis testing? For example, so when we typically say hypothesis testing, obviously we have a two data sets. So here it is written, a technique used to compare two data sets or a sample from a data set. Okay, for example, I have given one example of a drug, right? For example, a new company just want to test, for example, some viral disease. Okay, maybe you can say a new viral disease is hitting the market. Now few, the medical company, some of the healthcare company, they just want to test few drugs. They have made some drugs, and now they just want to compare the effectiveness of these two drugs. So how they're going to decide it? Obviously they will have a few samples, the drug samples, and based on those drug samples they will decide. Okay, they will take 500 people, maybe 1000 people, and they will test on it. So obviously they have some sample from a data set, so sample from the drug, right? So and then we draw some kind of a conclusion. Okay, for example, how you draw some conclusion? So for that you perform some kind of a test, for example, z test, t test. So if our sample is more than maybe 30, we take help of maybe a z test. If our sample is less than 30 or maybe around 30, we take help of this t test, that is a student test. Okay, and then we formulate some kind of a hypothesis, that is typically called a null hypothesis and alternate hypothesis. So how we typically make these null and alternate hypothesis? Let's see. For example, what we aim to gather the evidence, and typically there is a difference, effect, relationship, etc. That is alternate hypothesis, and there is something called a null hypothesis. Okay, so before I just show you this, let me just open this. Okay, on the right, and let me click. Okay, let me show you this. Okay, keyboard. So null and keyboard image. So let's say, okay. So how you will understand this, the null and alternate. For example, majority of the time we click, in the middle, if you have seen, okay, here. And least of the time you click here in the left side on the right side. Okay. So just understand that whenever we perform this hypothesis testing, you will see some kind of a bell-shaped curve. I will be showing you some graphs, but just keep in this mind the keyboard. You might have seen, you typically press somewhere in between. You do not click in the left, extreme left, on extreme right. Okay, so here you will see some kind of a significance on all that. Just remember this whenever a hypothesis testing you've been given. Just take this example of this keyboard. Okay, and I will justify you that why I shown you this keyboard. Okay, so now just see this one. So now how you formulate null hypothesis? For example, just spare let me spare some couple of minutes here, because this null hypothesis and alternate hypothesis is very difficult, because when I was in class 12th, I hardly used to understand that what is null and alternate, even my engineering day. Okay, so I used to confuse a lot in this. Okay, for example, a null hypothesis is something we try to cover that there is a no effect on it. For example, there are two drugs rolled out in the market. One is for example, for during COVID time, let's say. So the two drugs, they have claimed that this drugs is effective for the COVID, right? But the company, how they test the performance of these two drugs. So obviously they will have some kind of a null and alternate hypothesis. Okay, for example, in null hypothesis we say there is a no effect of these drugs on humans, let's say. So we are saying there is a no effect of these drugs on humans. This will be your null hypothesis. In null hypothesis we assume things in a natural way. We try not to engage any kind of effect, right? Just understand this. For example, there are two medicine, and we just want to test the hypothesis. We want to create some hypothesis. So the first hypothesis that we typically call it as a null hypothesis would be there is no effect of this drug on human, let's say. And your alternate hypothesis would be there is a effect of this medicine on human. Okay, so just see here what I have written. There is a no difference. So whenever you try to check and whenever you want to formulate a null hypothesis, we say there is a no effect first. And the second example which I just want to give you, for example, someone was convicted, not convicted, let's say someone is claimed to be, for example, someone is, caught in a theft case, for example, and he has been produced in the court. So the lawyer first, the null hypothesis would be he is not a thief. He is not a thief. Okay, and just give me a second. Just hello. अभी नहीं हूँ, मुझे इवनिंग में आप दे देना, ठीक है? इवनिंग 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 नहीं नहीं, अभी मैं ले पाऊँगा तो 1:30 या 2 बज जाएगा. अभी अभी अरे नहीं हूँ, ठीक है, करता हूँ बात आपसे. So where I was. Okay. So in null and alternate hypothesis, okay, so there is a no difference. Okay, now for example there is a drug. Okay, so the example of drug which I have given was there is a no difference, and if let's say someone is was caught in a this theft case, so the null hypothesis would be that he is not a thief, and for alternate it would be that he is a thief. So obviously the lawyers would try to prove that he is a thief. Obviously you have to bring some evidence, and then you will reject the null hypothesis. So ultimate aim is to reject the null hypothesis, but before that you just reject or accept a null hypothesis, you have to go with some kind of a data to reach out to those null and alternate hypothesis. That is a T and Z test. Okay, and there are many more tests also, but our primary focus is to how to formulate just null and alternate hypothesis, because once you are expert in formulating null and alternate hypothesis, you will be easily proven this acceptance and rejects of this null and alternate hypothesis. But you must aware that how you are trying to prove this null and alternate hypothesis. Okay, so now for example the court case which I have given. Okay, so null would be the person is innocent. Okay, and the alternate would be the person is guilty, right? So it means if you see this one, the whenever any case comes, first it is established that in a null hypothesis that he has not done any crime. Maybe if even the entire world know that he has done some heinous crime, but during the court trial it is established, or it is in the null hypothesis part it is said that the person is innocent, and the alternate would be obviously he is not innocent. So you try to gather information and try to reject the null hypothesis. This is how it works, the hypothesis system. Okay, it's not a typical case, but try to formulate. For example, if I have given you some kind of the case study, and I'm telling you to formulate the null and alternate hypothesis, your first aim would be that just to find out a way out to formulate this null hypothesis, that there is a no effect, there is a no effect of anything. If it is related with medical case, if it is a drug or something, you will say there is a no effect of this drug. You will start with a no effect, no interventions kind of a thing. that he is innocent or something, the ideal case. Okay, and alternate would be the reverse of that. Okay, this is how you typically formulate null and alternate hypothesis. Okay, so now let's say uh, there are different hypothesis testing. Okay, so it's a very much important that you know how you accept or reject any null hypothesis and how you formulate typically. For example, if you have some kind of a mean, okay, for example, let's say in your class, let's say there are two sections, section MBA section A, MBA section B, right? And these two sections have, let's say, 100 students, and you have been given some kind of a data analysis questions, and your marks have been calculated. Okay, and now you just want to check that the which you know class has performed well. Okay, so in that case we also formulate that the both class is performing well. It would be your null hypothesis, and alternate would be no, the both classes are not performing well. Okay, so this is how we typically formulate this hypothesis testing, null and alternate. And the way to test is the two way. One is a proportions if you have more than two samples, and one is a mean, right? So there is a t-test and z-test. Don't go with these things, the entire this visual, but just remember that there is something called t-test and z-test only. Okay, and the t-test and z-test, how and where you will apply, that is more important, right? So if let's say in the mean section, compare mean of a sample to be expected value, that is one sample test. If you have a two sample and you try to use this independent t-test, okay, compare the mean of a samples from two different populations. For example, in your university and for other university, so it will coming from the samples coming from the two different populations. Okay, maybe if I take a sample of India and if I take a sample of US, it means it is coming from two different populations. Okay, and compare the mean of two samples from the same population. For example, in your university and closer to some other university in the same state, so it means it is coming from the same populations. Or maybe within your university, maybe your you know the batch A and batch B, so obviously coming from the same populations. Okay, so this is how we typically formulate this kind of a hypothesis testing based on the mean. But if you see this, the way how you can remember this. Okay, for example, one sample, if you have a one sample, okay, the only one sample, for example, if you exercise, okay, so maybe you take some kind of a protein, right? So protein is one of the you know the key parameters to the people who do exercise, right? So it's the sample, let's say the sample size of let's say less than 30 people is taking the protein, and you just want to check whether the protein works on you know the you can say the physical endurance or not. So for that you will apply this t-test because the sample is less than 30. Okay, and you will try to check, for example, here the null hypothesis would be there is a no effect of protein on exercise, or maybe there is a no effect of protein on physical endurance. Okay, this could be the probable you know the null hypothesis. But what would be the alternate one? Alternate one would be there is a effect of protein on endurance or a physical activity, right? So this is how you come up with this null and alternate hypothesis. But what if your sample is more than 30? So how you gonna take the help of to prove you know the hypothesis testing? For that you take help of this there is something called a jet test. Okay, and if you have a more than two samples, okay, don't go the below part. The one is t-test, other one is z-test. But if you have a mean, okay, sample mean, and the sample mean has a two samples, so how you gonna you know apply this test? Okay, parametric test. There is something called one-way ANOVA. Okay, for example, if you are doing some exercise and Also, let's say you do 2 hours of exercise. This is 1 hour, and you are taking protein, maybe creatine, or maybe some kind of a food supplements, and you try to check whether there is an effect of bodybuilding or not. Okay, so in that case, you take help of this ANOVA, that is called analysis of variance. Okay, so I will be also showing you a few codes of ANOVA that you try to check the effect of something on people. Okay, so there are also a different way of ANOVA. One is two-way ANOVA, other one is Mankova, more than 2-3 samples. So ANOVA, Mankova, these things try to check the effect, cause and effect. If you have some cause and their effect on it. For example, if you take a protein, keratin, so whether there is an effect of there is some effect of bodybuilding or not. So that is the one way. Okay, that comes under your ANOVA, Mankova, if there are 2-3 factors. So these things can be checked out through the ANOVA, right? Now, how you formulate this hypothesis testing? Okay, so for that, for example, first we set up this null hypothesis and alternate hypothesis. Okay, for example, state null and alternate hypothesis, the step 1. Okay, here, and then there is something called select a significance level. Okay, I will be explaining what is significance level, but just remember that this is step 2, the label of significance. First step is to the state null and alternate hypothesis. At the same time, we decide the label of significance. Okay, the our the output, or maybe the answers which are coming, whether they fall under this significance level or not. Then we want to establish or apply that which test stats we will apply, whether t-test or z-test, depending on the size of the sample. And then we formulate some rules. Okay, so let's say if our value is coming, the p-value is coming out to be less than 0.05, then it is significant. If it is more than 0.05, it is not. Okay, and step 5, take a sample and arrive at a decision whether we want to reject the null hypothesis or accept the null hypothesis. So this is a typical approach when you formulate the hypothesis testing. We have to follow these steps. Okay, so now in z-test, for example, so how we calculate the z-test? For example, if here the formula is this, there is a small formula, z-test equal to x bar minus mu sigma root under n. Okay, so we in Python typically we have a simple or one line of a code. We calculate only the mean of a sample given and this population parameter. Okay, so in a simple code we can typically perform this z-test, but the main idea behind this z-test is, for example, when your sample size is more than 30, just remember that. Okay, the sample size is 30. So at that time you try to apply this z-test, because z-test will give you some kind of a label of a significance and all that. Okay, I will be explaining you all these things, but the major and the important part in the z-test is if your sample size is more than 30. Okay, then you perform this z-test. And for example, if you see, this is a well-shaped curve. If you will see, majority of your data lies somewhere here. Majority of your data lies somewhere here. Okay, and there are a few data which are lying on the two tails, the left tails and the right tails. Okay, that is why it is called a two-way test. Okay, the two-tail test, we call it a two-tail test. Few data lies here and few data lies here. Okay, so this is your z-test, but we try to see are samples which are coming out falling in this population or not. Okay, so in the t and z-test, okay, we will see that how we can perform this test. Okay, so now these are some of the formula. Okay, so how we calculate mathematically. Okay, so x bar here is your sample mean. For example, the marks of 100 students. Okay, this is your x bar, and this is your population mean. Okay, mu, and sigma root under n, population standard deviation and the sample size. You will be given all these things. You have to just find out the Z score. Okay, so Z score has some value. If it is falling, let's say, in the level of significance, then you have to reject the null hypothesis and accept the alternate hypothesis. This is how it typically works. Okay, and on the right side, if you see here, in a hypothesis, you have been asked to perform hypothesis testing and a standard deviation is given. And let's say your sample size is more than 30. So you will perform Z test. Okay, if it is not, then you will perform T test. Okay, and a standard deviation is not given, at that time also you will perform T test. So this is a simple thumb rule. Just remember that if your sample size is more than 30, go with the Z test. If it is less than 30, go with the T test. Just remember this one. This will help you out. Okay, because sometimes people get confused with this T test and Z test. Because this is the entry level question, sometimes it is asked that when you will perform T and Z test. Okay, so now I will be explaining you this curve also later on, but here just to establish that how this P value works. Let's say this is a bell-shaped curve. Okay, you have been given some samples, you perform Z test. Okay, and some value comes out to be 0.5. So there are two tail. Just remember the keyboard case. Majority of the time you type somewhere in between, but less of the time, let's say out of 1000 times you have pressed somewhere in the left side or maybe on the right tail of your keyboard, let's say. But majority of the time you just type in here. So if you plot it out, it will look like this. Okay, if it is falling here, then you have to reject the null hypothesis. Okay, so this is how it works. But just to explain you this, graphically, I have some slides, so I will be explaining you all these things because it's just the output of one of the program, that how your P value looks like and how your you can say the bale set look like. So how you gonna accept or reject it? It's just to establish the fact here. Okay, so whenever you see any questions, you will see alpha by 2 or something like this. Okay, and at that time you get confused that whether to accept the null hypothesis or reject the null hypothesis. Okay, so similarly the T test, when it comes to T test, it's the same as a Z test, but in formula there are some parameters it's changing. Okay, for example, X bar is your sample mean. For example, as 100 students, their marks, so you will calculate the mean. Let's say the mean of a 100 the sample of students coming out to be, let's say, 65 marks you are getting the mean, and the maximum was 95, let's say. So somewhere in the mean, if you are getting 70-75, you are better. Okay, if you are getting 70-75, it means you are falling somewhere here, right? So the T test, obviously, as we go by that, if your sample size is less than 30, we take help of this T test, and then we calculate this T score. The way we calculate the Z score, we come up with this T score also, and then we decide to accept or reject the null hypothesis. Okay, so this is how it works. Okay, now let's say the formula, there is a small formula, and this is maths. Okay, so don't go with the maths and all that. You have been given these things. Okay, just we have to calculate. For example, this is a formula of a T test, and in one of the questions you have been given all these things: the mean, mu, S, and n. The sample size is n, 30. That is why you're taking help of this T value, right? And when you put all these things in a formula, T is coming out to be 10.96. Okay, but how, I mean, what does it mean 10.96? Whether it makes some kind of a significance or some kind of information or not, right? So we calculate based on this T. You if you remember that class during the class 12th, at the back of the maths book, we have some kind of this the value, if your T test and Z score value at the last. So based on this 10.96, we have to find out what will be the alpha value. So we have to check in that chart whether alpha is less than 0.05 or something. So this is how you calculate, because it is a standard, right? If t value is coming out to be 10.96, so what would be the alpha, right? So this is how you accept and reject the null hypothesis. But here my aim was to show you how you calculate the t-test, but your work is not to go with this math formula, because in a Python, if everything is given, you have to just put in and your program will give you the result, even the alpha and everything, right? But you know how to interpret it, because once data is given to you, your task would be to how to interpret it logically. Because let's say my program is giving 10.96 the t value, but I'm not able to figure out that what does it mean, right? So whether I have to accept the hypothesis or reject the hypothesis, at that time you get confused. Okay, so now the p value, let's say the best way to remember that, if p low, let the null go, right? This one, just remember that, because someone has given me this maybe 5-6 years back. Some of the professor has given me this. If p is low, let the null go, right? If p high, let null fly. Okay, so if p is low, you have to reject the null hypothesis. If p value is high, accept the null hypothesis. This is how it works. Okay, so if sometime you get confused, just remember that this one. Okay, so if p value is low, accept the null hypothesis. If p value is high, reject the null hypothesis. That is why if p is 0.49, you have to accept the null hypothesis. Okay, you have to reject the null hypothesis. Okay, and if it is higher than that, then you have to reject. Okay, this is how it typically works. And these are the some you can say the approach of null hypothesis. For example, as I already told you, very in a keyboard case, very unlikely observations is here. Okay, very unlikely. Okay, so just give me 30 seconds. Okay, in a keyboard case, as I already told you, that very unlikely you are going to touch this part of a keyboard, but majority of the time you will touching this one. Okay, the same way here, very unlikely observations, very unlikely. For example, if there is some gesture attached to your laptop, and if I try to find out where you during the keyboard press, where you have pressed it most often, it will be in somewhere in the middle, right? So this is how your the label of significance comes into play, that where you have majority of the time your populations or maybe your samples falls in, whether it falls under this one or here, somewhere here. If it is falling somewhere here, you have to reject, right? You have to reject then this hypothesis. So this is how it typically works. Okay, but this is a more of a maths. I'm not making it a more, I don't want to make it a more complex, but I just want to show you that if something like this comes in, at least you will have some visuals to make connections that how your hypothesis testing typically works. Okay, so as I already told you, there is something called a two-tail test. Maybe there is something called a right tail test and left tail test. So when you merge these two together, we come up with this two-tail test. Okay, so in two-tail test, obviously these are the equal parts, equal proportion. This is 95% of the area, and this is 2.5, and this is 2.5% area. Okay, but the interesting thing is that when to accept and reject the hypothesis. Okay, as I already told you, 95% of your data will fall here. 95% of the time you will be pressing the keyboard here in this area. Maybe the 2.5% you will be falling here. So in this, if you are pressing it here, or maybe your sample is falling somewhere here, after calculation of the p value, if it is falling somewhere here, you have to reject the null hypothesis here. Okay, you have to reject it. Okay, here. So this is how it works. But for that, for example, let me show you some of the the use case. Let me jump on to the use case here, and then I'll come back, okay, to this case. Okay, I'll show you. So now let me just jump onto the case so that it makes some sense. Okay, now for example, a passport office claims that the passport applications are processed within 30 days. Okay, so this is one case. A passport office claims that passport applications are processed within 30 days. This is the claim of a passport office. Maybe you are applying for some visa, maybe in US, for US, that you want to pursue maybe the MS degree or maybe PhD in data science or something. And now you went on to this passport, the office, and their claim is that they process your visa and all that within 30 days maybe. Okay, so once you submit your passport application, it is processed within 30 days, submitting the application form and all necessary documents. Okay, and the file, and obviously this is one case where, let's say, the passport.csv, this is a data set have been given to you, and contains it contains processing time of 40 passport applicants. Okay, there are a list of 40 applicants and their data is given to you. Okay, that the 40 passport applicants are there, and how much it takes. Let's say maybe the first applicant who applied for this passport, their visa might be their application their application was processed, let's say, in 25 days. There are people whose application are processed in 35 days. Maybe there might be a few people in the outliers, 45 days, maybe 50 days, but majority of the people might be in 20 to 30 days. Okay, that is why they are claiming it to be 30 days. Maybe it's a mean value. Okay, it's a mean time, and the data for 40 passport applicants are in this passport.csv, let's say, and I will showing you this passport.csv dataset also. Okay, and you have been given the population standard deviation of processing time is 12.5 days, and you have to conduct a hypothesis test at significance level of 0.05. This is the significance level. You can say that these are the tail, that it should be at least p value should be 0.05 or alpha should be 0.05 at that time. Then only you will reject the null hypothesis. Okay, to verify the claim made by the passport office. Okay, so in this case, the population mean claimed to be the passport office and the standard deviation are known. Okay, so in the formula, let's say the sample size is more than 40, it means you will apply that test, and you have been given this standard deviation of 12.5 days, and obviously the mean is 30. As I already told you that it takes processing time is 30 days. It means it is a mean value, right? Population mean. So you have been given this population mean and population standard deviation, and sample size is 40. These all things are given to you, right? And the data set is in passport.csv, contains observation of actual processing time of 40 passports. Okay, and we can calculate the mean of these observations and calculate the JAT test. Why we are calculating the JAT test? Because the sample size is more than 40. Okay, it is more than 40. If JAT stats value is more than minus 1.64 critical value for the left tail test, then it will conclude that processing time is not less than 30, but it is higher than JAT test is less than minus 0.5. So now how you are going to formulate the this null hypothesis and alternate hypothesis. So here the passport office is claiming that it takes 30 days to process your applications. So here you will say that in a null hypothesis that the passport office is not taking 30 days, okay, to process the applications. Okay, and in alternate you will say the passport office is taking 30 days. Okay, so this is how you have to formulate it. Okay, so now here in passport.csv, this is a Python code I will be showing you. but just understand that how it is working. Okay, here. So we have some of the libraries which we have used. Matplotlib. Okay, something to plot, but here it is not required, but you can use it if you are plotting some kind of a graph. Okay, so pandas.pd is for processing all mathematical stuff and all that, and also uploading this CSV. You require a pandas, and we have some stats model. Okay, and API OLS. Okay, for that this statistical models and ordinary list squared. Okay, so these are the some libraries that in a Python you will be using it. Okay, and now my data is in passport.csv. It is saved somewhere. This is my desktop location. C neural network MRMSL861 and passport.csv. Okay, so my data of 40 passport applicants data is somewhere in this location. Okay, and I am reading it, read CSV, and storing the data in a passport. Okay, so my entire data now, CSV data, is stored somewhere in a passport. Okay, and I'm just trying to check that in when you pressing the head 5. Okay, the 5 observations will come and their processing times will come 16, 16, 30, 37, 25. This is the processing time. Okay, so the first applicant who have applied, the passport office has taken 16 days, for second 16, for third 30, fourth and fifth 37 and 25. But what passport office is claiming that it only takes 30 days. It means they have some mean value, based on the mean value. And how you verify their claims? Obviously you will come up with some kind of a null and alternate hypothesis, and the sample size is more than 30, so we will take this help of a JAT test. Okay, now I just want to know that the all 40s passport applicants, what was the processing days, obviously in terms of a time, right? For example, first was 16, 16, 30, 30, 37, 25. If you see, there are some applicants whose processing time was more than 30. There are a few, one is 35. If you see, there are 38 also, 41 days. Okay, and there are people maybe 27, 21 days, 18. You'll see there are a few more. 16 is the minimum, I think. 16, yeah, 16 is the minimum days. Okay, so they might be, they have some documents and everything. So it took 16 days and maximum is 38 days. So this is how you see that whether the claim is by the passport office is verifiable or not, and whether they the claim is established or not. So to establish the claim, to verify the claim, you have to take help of this JAT test. Okay, so now there are some formula, right? The same formula which I have been which I shown you. That is why in this Python programming you will see the same kind of a structure here. That is why I was showing you the maths formula. So here we have a different library, import math, from SciPy import stats. Okay, and then we have to define it, the one function. We are defining a JAT test, population mean, that is the pop mean, population standard deviation, it is given, and the sample size. And this is the JAT score formula because the sample is more than 30. So sample dot mean, this is a formula, the same one which I have shown you, minus sample dot mean minus population mean divided by population standard deviation, then the square root of this sample. This was the simple formula was there, and we have to return the value, whatever is calculated through the JAT score, we have to return the value. Okay, so once you run this code, now you have to pass in this JAT test. Now this is function, you have to pass this one. So 30 was the mean value, 12.5 was the standard deviation, and the processing time which they have called it. Okay, what was the processing time? Okay, it was some passport dot processing time. Okay, so if you pass these 3 parameters, based on this, your the Python is giving you minus 1.49. This is a JAT test value, but whether this alpha value 0.06. Okay, this one is the p value here. So if you see, This is the Z value, and this is corresponding the the P value. Now, this two will help you to accept and reject the null hypothesis. So, the P value is more than 0.05. Okay, it means null hypothesis is written. It means it takes 30 days to process, right? So the P value is more than 0.05. It means the samples coming from the population. It means kind of a keyboard which I have shown you. The majority of the people pressing on in somewhere in the middle is the same thing. It means it is more than 0.05. It means your null hypothesis must be retained. Okay, had it been 0. Maybe 49, you would have rejected the null hypothesis. Okay, so this is how you can accept or reject the null hypothesis. Okay, second case is here. For example, here in this case, the second case, you have been given this case might be given in your examinations, that how you calculate this hypothesis, how you formulate this hypothesis, and how you conduct it. Okay, so for example, this UTV, motion production, and they have newly formed movie house. Okay, and they are interested in the production cost required for producing a Bollywood movie. This is their business case. They are interested in to produce some of the movies. Okay, and the industry believes that production house will require 500 million, I mean 50 crore on average, to produce a movie like a Barfi movie, right? So maybe before producing this movie, they were deciding that how much they require. So the production cost, the EP was interested in understanding the production cost required for producing a Bollywood movie. The industry believes that production house will require 50 crores on average, at least 50 crores, so that they can produce a much better movie, at least of that level. And it is assumed that the Bollywood movie production cost follows a normal distributions. It means majority of the movie, at least they take 50 crores to produce, right? If it is let's say 30 crore or maybe 20 crores, movie will not be of that quality. But if you are investing, let's say 50 crore, obviously your movie would be of that level. So also the production, they assume that the production cost follows the normal. It means normal distributions means majority of the movie out of 100, maybe 85 movies, somehow spend this 50 crores to produce a movie, right? That is why it is saying a normal distributions, because majority of the the populations touching in the middle, right? That is why I am showing you this keyboard. The same thing here, the majority of the movie makers spend this 50 crores to make a movie, but there are a few people who have produced a movie maybe in 20-25 or 30 crores budget. Okay, maybe they are on the left tail, right, on the both tails, right? So the production cost of 40 Bollywood movie in a millions of rupees are given. Let's say you have been given this 40 movies name and their production cost. This is also saved somewhere in bollywoodmovies.csv file. Okay, now we have to conduct appropriate hypothesis testing at alpha equal to 0.05 to check whether the belief about the production cost is correct. Okay, so obviously the movie makers is saying that okay, it takes 50 crore to produce a movie. Okay, so let's say assume that okay, it takes 50 crore to produce a movie. Okay, any alternative will say no, it doesn't take a 50 crores to produce a movie. Okay, and then you will apply the same concept here to come up with the acceptance and rejections of hypothesis testing. For example, so here if you see the data here in the case, it is given the data. If you check what you have been given, the 40 Bollywood movie list, it means you will apply Z test because the sample is more than 30, and the 50 is the average, somewhere it is a mean value. Okay, and you have been some kind of, you have to follow the normal distributions, so you have to find out the average, and the significance level is 0.05. So these things you require while putting all these data in a Python. So in this case, population mean is 500, it is given, and the sample set for actual production cost available in the file you have to find out, because there is the 40 movies list, and their cost is there, so you can calculate the mean value from this. And the population standard deviation is also not known here, it is not known. Then how you gonna apply it? Okay, so everything is there. Now we will apply it in a Python, that how you can calculate it in a Python, right? So same approach we will follow here. So I'm showing you that how you can calculate, because it's just a simple line of a code. So data is given, the Bollywood movies data, 40 Bollywood movies, and their production cost is saved in bollywoodmovies.csv. We will have these all libraries there. Once you type in all these libraries in a any code, maybe you will be using a node, maybe the VS code, or there are many sophisticated this Python framework where you can run this code. Okay, so you will be using this all the libraries. You have to type in all these things, and I am saving Bollywood movies. This is one user defined my variables. So in this variable I am saving all the Bollywood movies.csv data. Okay, and I am reading it through .read CSV function, right? Because my data is in CSV, you cannot write it in Excel. Read, then command on Excel, you cannot write it. Okay, so you will be writing it as a pd.read CSV, because data is in CSV. And now I just want to check the value, the production cost. So let me jump on the last in for this line, that the first movie was produced in 6014 million. Let's say 60 crore. It's a 62 crore. Let's say it's a 33 crore. Okay, this is 66 crore, this is 25 crore, this is 33 crore. Okay, so if you come up with this the mean value, okay, and the claim of this production house is that 50 crore is the amount in this you can create a better movie, right? This is the claim, right? And they also require a 50 crore to produce a movie, right? Whether their claim is justified or not. So we will take a help of this JAT test. Now we have a more than 30 samples. Now we will be applying this JAT test, the same thing, and to verify the claim of this production house, right? So now we have this yeah.
Sir, in this question, standard deviation is not known, so we will use t-test na for this.
Standard deviation, if it is not given, okay, so there is something called here we have this previously I have shown you this. 1 minute, this, you're right somewhere, there is one minute. Where was the
Yes, sir.
this one?
So flow
Yeah,
chart.
this one, flow chart. Okay, so if you have this one, okay, then we will be using this sample test, t-test only. Okay, okay, so we will be using this if it is not given. Okay, so we will be using this t-test only, but that is an independent t-test. Okay, where is that? Yeah, so here this is JAT test. Okay, but here if you see this one sample test. Okay, this is t-test, one sample test. Okay, the value is here. Okay, the production cost and everything, and we calculate this p value, that is a less than 0.05. Okay, less than 0.05. Now if it is not given, right, so we have to consider it as a t-test only here in this case. Okay, so hypothesis testing was that in your null hypothesis that it takes 50 crore to produce a movie, but in alternate test it is saying it is not, right? So this implies that sample mean is less than the population mean, and only 2.7% probability of being part of the distribution with the population mean of 500. As p-value is less than 0.05, you conclude that the sample mean reject the production cost is equal to 500. Okay, so the claim of the production house was that it takes 50 crore, but as the value is, the p-value is less than 0.05, it means majority of the movie takes more than 50 crores to produce. Okay, the majority of the production house takes, they have to invest more than 50 crores. So in that case, obviously the claim of the producer is rejected. Okay, so in this case, now if you see this one, in this case, let me quickly go. Okay, where was that? So comparing the mean of sample to different populations, okay, if it is a proportions and if it is a mean, okay, so in that case we have to take help of this. So compare the mean of a samples from two different populations, two sample independent t-tests we have to apply. But if we have to compare the mean of two samples from the same population, then you have to take help of this sample t-test. Okay. Now, before I go to this, okay, this one. So as it is already saying, T and Z test. Okay. So now, if let's say this is called a student distribution test, and your population variance is unknown here in the last example. Okay, so that is why it is applying this t test here. If it is known, then you will go with this z test. Okay, but majority of the time, if your sample is small, it means if your sample is less than 30, then you take a t test. But if your sample is less than 30 and this population is unknown, then you take help of this t-test only. The formula is same as a JAT test, but because it is population variance is unknown, that is why you are taking help of this t-test. Okay, and it follows, the t-test follows the t distributions, and it is follows the normal distributions. If you plot the graph of this, even if this, I have a 40 data points, and if I plot the graph, somewhere it will look like this, the bell-shaped curve. Okay, there is no issue with the bell-shaped curve. It will somehow look like a bell-shaped curve. That is why it is called a, this normal distributions. Majority of the points fall somewhere in between. That is why on the top it will have the major of the mean value falls in between. Okay, so now just quickly show you this p value. Okay, here. So graphically, that is why I put in this graph at the end. So let's say this is type 1 and type 2. I'll come back in this slide, but before that, let me show you this. Now we have calculated the z value. Okay, in those two examples, those the case. Now here in the first pick, if you see 95% confidence is there, and this is, let's say, z test, z value is there. Okay, plus 1.96 minus 1.96. If it is falling somewhere here, we have to reject. In this case, the this movie, Bollywood movie, it is saying that the value was coming out to be 0.02 or something. It means falling at a rejection level. Okay, that is why we have rejected the null hypothesis that every production house minimum required, let's say, 50 crore to produce a movie. That was our null hypothesis. But when we calculated the this z test only, but it was a t test because the population variance was unknown. In that case, our the p value was coming out to be 0.05, less than 0.05. That is why we rejected the null hypothesis. It means our the sample is not coming from this area. The sample is coming from this area, right? So we are not 95% sure. It means maybe you have experimented 100 times something, right? And out of that, only 2 times you failing, right? or maybe at that time then you will have a confidence of maybe 5 times you are failing, right? But 95% you are getting success. That is why it is called a 95% confidence level. So now you are confident enough that if you do some experiment 100 times, only 95% you will get a success, only 5% you will get fail, right? So this is a confidence level. Second, we call it a critical value. So if any p value falling here in this red area, this is called a rejection region, right? This is called a critical value. So in a Z test or T test, we calculate this critical value. Okay, these are the critical value, the Z value. I'm showing you this graphical the Python. Through Python you have seen it, that how the value comes out. It's cooked up, everything is cooked up. You have to fill in the value and your program will give you all the data. But how it looks like, right, that the value which are coming, how you interpret it, right? So let's say Z score, in some test or experiment, when we have calculated the Z score, it is coming out to be 2.6. Okay, so in 2.6, and the value when you calculate corresponding to 2.6, it is coming out to be plus 1.96 and minus 1.96. That is your rejection region, right? This is how it is drawn. So the critical value, the Z score value corresponding to 2.6, let's say is coming out to be critical value of plus 1.96, because it's a two-tailed. So same distribution is on the left side or on the right side, but it is on the left side. That is why it is coming out to be minus 1.96. But on the right side, it is coming out to be plus 1.96. For example, this is 95% area, and this is, let's say, these two are 5% area. So one is plus 2.5 and this is also plus 2.5. But as it is on the negative side, that is why putting out to be minus 2.5 here. Okay. So this is your rejection region. So p value falling in the red area will reject your null hypothesis. Just remember that. Okay. So p value coming falling in this area means less than 0.05. It means it will fall somewhere in this area. You have to reject the null hypothesis. If it is more than 0.05, it means somewhere falling in this between, the larger area. Okay, that is why you have to accept the null hypothesis. Okay, now these are just a way to represent it, that how it looks like, critical value and all that, and significance level. So when we call it say the alpha, the significance level 95% or maybe 0.05, we are saying that the population should come from this level of significance. The population coming from this area only. Okay, if alpha is coming, if alpha is given 95%, okay, it means the majority of the population is here. Okay, now under 5% is, let's say, is this area. This area is 5%. Now how you converted 0.05 and 0.05 here. Okay, so graphically I am showing you that how this bell-shaped curve looks like, and how typically we calculate it. Okay, so if you add it up, 90.95 plus 0.05, these are the two tails. If you attach it together, it will cover the entire population, the entire bell-shaped curve. Okay, now that is why it's called a 0.05 alpha level. Okay, this is just a mathematical way to calculate. Okay, but my point is that when the level of significance is somehow it is maybe in the questions it is written 95% of level of a significance, or maybe sometime they write it 0.05. So don't get confused, they are talking about this area only, this area, this bigger area. Okay, so this is just how we calculated this one. Okay, so don't get confused with this. Okay, these are just graphical way, alpha by 2, alpha by 2. Okay, and sometimes they write alpha by 2 value. It means they are saying 0.05. Okay, if they are giving you alpha by 2 value, it means they are talking about this tail value, that is 0.05, only 0.05. Okay, these are the different way to put things. Okay, and the confidence interval, this is a mathematical formula. And because in Python, if you see some complex way to come up with this confidence interval, don't get confused. That is why I'm showing you this formula, so that once you type in, you will remember that, okay, x bar, what is x bar? Plus minus z alpha by 2 sigma by root n. This is your level of a confidence. This is a confidence interval. This is nothing but this area plus this area. This is just a formula of CI, confidence interval. Okay. And the p-value here, how you calculate the p-value? P-value is the probabilistic value, the entire probabilistic value. Okay, this is the p-value. Okay, so now if you add, the p-value is 1. So 95% is this area, bell-shaped curve, this from here, and 0.05 is this, and 0.05 is this. This is the one area. Okay, so now the entire the bell-shaped is 1. Okay, this entire one, this area, this green one is 95, and this red one is 0.025 and 0.025. Okay, so this is your the making it entire bell shape to be 1. That is, area under this curve is 1. That is 100%. But the rejection region is this this red one, you can say, this red one, yellow one. Okay, so once your alpha falling here, alpha value falling here, it means you have to reject the null hypothesis. It means your sample is not coming from the broader population, it is coming somewhere in the tail, that you are not confident enough. Okay, so this is how it works. Okay, so now, in this one, let's say the p-value, as in the Bollywood movie, let's say p-value was coming out less than 0.05. It means somewhere your value was falling somewhere here. It means the claim of the producer was that it takes 50 crore to produce a movie. That was the claim. But once you calculated of 40 such Bollywood producers and their movie, and what was the cost of production of each movie of 40 Bollywood the production house, then you realize that no, it's taking more than the 50 crores, and that is why the p-value was coming out to be this one, in this range. That is why we were rejecting the null hypothesis. The claim was the 50 crore to produce a movie, and then you have rejected the null hypothesis because it was falling in a rejection region. The p-value was falling in a rejection region. Had it been falling in the acceptance region, maybe value is more than 0.05, let's say, so it means it will fall somewhere in the acceptance region. It means the established fact is that the Bollywood producer requires 50 crore to produce a movie. It means now it will become established fact. Had it been in this area, had it the p-value more than 0.05, okay, 0.05, okay, but your value was, it is coming out to be this, in this region, rejection region. That is why we are rejecting the null hypothesis. Okay, so the p is nothing but a probability value, as I already told you. Okay, so this is just a graphical representation that how you project this p value. Okay, so the p-value, obviously if it is coming out to be less than 0.05, so this is how your graphs looks like. So okay, so okay, now I was talking about this, that how you typically calculate. Now your Z score is coming, let's say Z score is coming 2.6. okay, so corresponding to 2.6, it is established fact that if it is coming, Z value is 2.6, your this p value is gonna come 0.0047. If you see this one, it means somewhere corresponding to Z value, your p value is 0.0047 here. It is falling somewhere here. Okay, so in a maybe in a class 12th, maybe at the last page somewhere we had this kind of a table, right? That once you calculate the Z value, then you used to see that what is the corresponding value here. Okay, so this is how corresponding to Z you calculate now here. But in a Python programming, we have a sophisticated way to calculate. If you are able to calculate the Z score, also it will give you the p value, also corresponding to the p value. and based on these p-value, you will be able to accept or reject, or maybe you will be able to establish a fact, or maybe you will be able to reject a fact. Okay, so this is how your p-value works typically. Okay, so the same thing is here. Z score is here 2.6. Okay, corresponding to 2.6, we have this value, p-value of 0.0047, and the p-value which you have calculated corresponding to z score is less than 0.05. It means your sample is falling somewhere here. Okay, the sample. It means you have to reject the null hypothesis. Okay, this is a mathematical way. Okay, so the critical values and everything, this is how it works. Okay, so now let me show you the Python code. Python code is there. Okay, so we have one of the PPT. Okay, let me go up. So this one, that test. Okay, where was the one PPT? I just missed out. Yeah. So the type 1 and type 2 error. Okay, so now let's say there is something called a confusion matrix. Okay, you might have come across this confusion matrix because it's sometimes it looks like a square, and whether you know how you formulate it. For example, there is a case of a regression or maybe a logistic regression. Okay, for example, someone has a COVID or not. That you have, let's say, 1 crore of a data of some patient's data, and based on that you are training a model, right? And now an unseen patient comes in, and you are capturing there some of the input parameter, maybe the temperature, maybe you can say the taste of the food and everything when he eats, and maybe the blood pressure, BP, maybe if they have some sugar, right? Something like that. Okay, and the high temperature or everything, right? So these are the some parameters which you are capturing for an unseen patient. I mean, unseen means the model haven't seen this the data earlier, and based on those 1 CR of a data, you have trained some model on a logistic regression. Now you want to classify whether new patients which have their details are with you, whether he is a potential the COVID patient or not. Okay, so based on that, let's say if you have a more unseen patient, so then you draw some kind of a confusion matrix and try to check your performance of your model, whether it is performing or not, right? For example, how efficient your model is once you have made it on unseen data, how your model is performing on unseen data, right? So for that you have to take help of this something called a confusion matrix. Okay, for example, here in case of hypothesis testing, let me go on the right side. Okay, so this is a test result and this is the actual condition here. Okay, so verdict of guilty, let's say in the test result there are two types of a test in a court. Either he will be guilty or he is not guilty. Okay, maybe actual condition would also be like he will be guilty and he may not be guilty. Okay, this is the court condition and this is actual condition, let's say. Okay, if actual condition is that he is a guilty, okay, and the court is also saying he is a guilty, it means it's a true positive. It means the guy is obviously true positive, means your actual and the factual both are true. It means it will come under true positive. For example, you predicted that somehow based on some parameter you feel that he has a COVID, but when it go for some kind of a test in medical examinations, he found out to be that he has a COVID. It means it's a true positive case. The same case, let's say you have a trained a model and your model is also saying that he has a COVID. Okay, and in the test data also it is saying he has a COVID. So in that case it will be a true positive case. Okay, true negative is that, let's say in the true negative, what is that? For example, in actual condition he is not a guilty, but it also saying he is not guilty. It's a negative case. Okay, it means unnecessarily we are dragging that person, right? It's a true negative. But we try to find out the people who are in the positive. We do not want to go away with. Okay. So, and there might be a case, if you see that there is a mismatch in this left. Okay. Just see what does it mean. For example, a person actual condition is he is not a guilty. Okay. 1 minute. Just 30 seconds. Okay. So let's say there is a one case. Okay. So for example, in a court of law, actually the condition is that he is not guilty. He is not a guilty. Okay. But in a law of court, he has been proven guilty, right? For example, someone doesn't have a COVID, but due to some medical test and all that, it is coming confirming that he has a COVID, but actually he doesn't have. Maybe due to some the sampling error, or maybe some kind of equipment failure, something like that. Maybe some if someone has changed the sample or something. Now your you can say the data is showing that he has a COVID, right? So this is one case, and I will be explaining you what is danger in that. Second case, someone is not a guilty and court is proving them to be guilty. Let's say in some case some guy was not guilty, but the court of law is saying he's a guilty and is sentenced for 10 years of a jail, let's say. Okay, the one case. Second one, if you go, let's say in actual condition someone is guilty. We'll take the both case. Someone has a COVID, but your test is saying he doesn't have a COVID. Okay, the one case. Let's say someone is guilty, but your court of law is setting him free, right? This is the two case. So where the threat or danger lies. For example, during during the COVID time, it's like a communicable disease, as per my understanding. Whenever you comes in the contact of that person, likely is that you will have that COVID, right? The more chances of you get affected with the COVID, right? So these are the the threat at that time. So you cannot spare the people. You cannot spare the people. You cannot go away with this kind of a people. So the person who had the COVID must be taken care of. So it in the model which you have trained somehow got failed, right? This is a type 2 error. In type 1 error, someone is a guilty, someone is not guilty, and you are saying a guilty. This will work, but the person who are guilty, you are saying he is not guilty, right? That is a danger, right? Someone is, let's say, someone has done some heinous crime, but he is still getting away with the law, right? And the law is proving that he is not guilty. So how danger is for the society, right? So that is why you have to take care of this type 2 error. So let me build some case. For example, in an interview, maybe interviewer may ask you what is type 1 and type 2 error and which one is more critical, right? So in type 1 error, you just remember that someone doesn't have a COVID. Just remember this way, and your medical system is saying that he has a COVID, or maybe someone was not guilty and your law of us your law is saying to be a guilty, right? But someone is a guilty and the law is setting him free. That is a the more problematic one. So this one is a type 2 error. So in the type 2 error, you have to take care of all these things. Okay, it's very critical. For example, in ICICI Bank, you have applied for a loan. Okay, so obviously how loan banking system typically works. So they have, let's say, crores of data of customers. They run sophisticated AI/ML models. Maybe they have trained their model in, let's say, a decision tree. On decision tree, maybe random forest, maybe logistic regression, or maybe artificial neural network. that based on the 1 crore or maybe 10 crores of the consumers data, they have trained some models for giving loan, right? So based on the, let's say, 2025 parameters, they decide whether the loan to be given to particular person or not, because, and they also try to check maybe who will be the fraudulent customers. So the type 1 and type 2 error, if let's say if their model is able to detect early that this guy will not pay a loan, he may proven to be a defaulter, right? So in that case, they obviously a bank will not take a chance, right? So in that case, they have to take care of type 2 error. If your model is giving you a type 2, more type 2 error, it means you have to how to minimize this type 2 error. Okay, type 1 error is fine somehow, depending on the business requirement whether your type 1 is error, but majority of the time type 2 error is more dangerous and more problematic for any business, because type 2 error is something that create a problem for you. So in a banking case, if someone is potential the fraudulent, and your system is saying he's not a potential fraudulent, and your bank is giving a loan, just see how much damage he's gonna do in the future, right? So that is why we have to take care of this type 2 error at the same time, right? So in an interview, people may ask you that how to minimize this type 2 error, and how to minimize this type 1 error, right? Maybe the answers may vary, but here my the point of discussion is that in terms of hypothesis testing, you are now coming up with this type 1 and type 2 error, okay, and now you are deciding it that how type 1 and type 2 error in a confusion matrix looks like, and why type 1 and type 2 error comes in, okay, and where we will call it a type 1 error, and where we will call it a type 2 error, and what will be the approach to solve this, how to come up with this. Because in a business, people will ask you that if type 2 error is more, let's say 50% is a type 2 error in your model, right? So how are you going to minimize it? Out of 100, 50 people might be the fraudulent, right? Your system is detecting it. So obviously your boss gonna ask you that how you gonna reduce the this type 2 error, so that obviously you can save a lot of money for a bank, right? So these things will come when you formulate this, when you come across the classification case, and the base of these classification problems is also somehow associated with hypothesis testing, okay. Then you come up with this kind of a type 1 and type 2 error, okay. So in this, here if you are rejecting this this is just a mathematical way, and this is one elaborative, you can say the descriptive way to understand. You can also say when h1 is alternate hypothesis is true and you are rejecting a null hypothesis, then it is a correct decision, this is a correct decision. But when your null hypothesis is true but you are rejecting the null hypothesis, this is type 1 error. This is a mathematical way to say, but my point is that just remember in this way that if someone is not guilty and you are proving to be guilty, this is type 1 error. But someone is guilty and you are saying he's not guilty, then this is a type 2 error. So type 2 error is more threat and more dangerous and to be taken care of in every single business, okay. So this is how your entire hypothesis works, the classification problem works, and you can manage it through different tests, that is Z test, T test. There is also something called F test, ANOVA, MENCOVA, and you can perform all this kind of a test to come up with this, okay. So this is how you can formulate all these things, okay. So now let's say we come across this case and all that, okay, and let's say, so just remember this population sample and all that, and let me just come across, just follow this one, okay. So let me just spare a couple of notes here. If you see this one ANOVA in coming class, ANOVA is very much the interesting one, because you might have heard of something called experimental design. Maybe there is something called pre-test, post-test, maybe in the research for methodology and all that. So in that they have something called the control group. There is something called experimental group. Okay, so my point is that ANOVA is one of the way to analyze the cause and effect, the causal effect. There is something called correlation, and there is something called this one causation. Okay, so the causation part is something, for example, if you are let's say let's say sales and revenue. So if the number of sales will increase, the number of revenue, the amount of revenue will also increase. So the two parameters are linked to each other. Okay, so if let's say there is a less pressure, maybe there is a highly likely chances of a wind, right? So these are the two parameters which are correlated. Okay, but there are a case, sometime it happens in a life. Okay, so let's say if the number of tweets are more, maybe some countries, maybe their revenue gets doubled or something. So it's not a cause, it's not a correlation, and it's also not a causation, you can say. Okay, maybe these two are correlated, because number of someone giving a more tweets, maybe the revenue of certain countries also goes up, right? So these are two correlated things happening together, but it's not a causation. Like someone is tweeting more, it doesn't mean the revenue, or maybe something of XYZ country will go up. It's not a causation, right? So that is why the correlation and causation is more important to understand. Okay, because when you say correlation and causation, and the causation can be judged out through this ANOVA. Okay, so the cause and effect, the causal effect can be calculated through ANOVA. So in coming class I will be showing you that how you can apply this ANOVA, and there is also this F test and all that, and we will go with that. So let me conclude this session, and let me come with the first slide somewhere here. The null and alternate hypothesis, just remember this one, and T and Z test, that in null hypothesis we try to capture this, there is a no difference. Okay, and in alternate, obviously, if there is some effect of something, maybe a drug or something. So to formulate these two, null and alternate, we have to take the based on the use case. Sometimes you may get confused that what to write in a null and what to write in alternate hypothesis. Okay, but just remember that you have to capture the ideal situation. You have to capture the ideal situation in null hypothesis, and if there is some effect, that to be considered in in alternate hypothesis. And then based on the evidence, based on the sample, we try to reject the null hypothesis or fail to reject the null hypothesis. Okay, this is the entire process once your data is given. Okay, so this is how your hypothesis works. Okay, so let me conclude this session. Okay, so okay, Dipti, just take attendance and let me share this today's PPT. Okay, so let me upload it and you people just go and check. Okay, so Dipti, are you there?
Yes, sir.
Yeah, take the attendance and let me upload today's session's PPT. Okay, meanwhile.